Hello, welcome to Mr. CFD. In this video, you will learn how to generate the geometry and mesh of this product, airflow around an aircraft in ANSYS Fluent software. Let's start generating the geometry. First, open a workbench window. When the workbench window is opened like this, from the toolbox, component system, choose geometry and drag it to the blank window of workbench. Then right click on it and select space claim as the software to generate your geometry. Click on it. This is space claim window, and for geometry, generating the geometry in this problem, first we have to read the IGS file of the base geometry, which is the aircraft. To do that, go to File and then click on Open, and choose the file that you are going to open as the base geometry. Yes, here it is, base geometry, that is in IGS format. Open it. So this is the geometry of the aircraft, like this. And checking the structure, this is the solid. And now we are going to make the domain around it. Actually, the domain around this aircraft is a cubic in which the length of sides is 60 meters. To create the domain around, first from select option, we go to plane and create section in this toolbar, and then click on the origin of the coordinate, so these three planes are created. And now I want to decide which plane is needed for starting drawing the domain around. Back to select, and then I want to use this plane and move it. Then by creating a sketch on it, start to draw the domain. So go to structure and hide the other planes. Okay, and now click on this plane using move command in edit section. I want to move it until it is reached to this point. To do that, we have to use up to option, then select this point, and as you see now, the plane is here. It's because I want to define how long is the length in front of the aircraft in the domain I want to create. Okay, now from this point, I have to move the plane about 22.5 meters. Or this value as a millimeter. We can go to File and a space claim option to change the unit from the millimeters to meters. So from this list, click on units and then change the length from millimeters to meters. Then click on OK. So now the actually unit is on meter. Okay, now I want to create a sketch on this plane, so click on a sketch. Sketch is made on this plane, and then look at your geometry in this view. And now from this point, I want to create a square in which the length is 60 meters. Yes, here it is. As you see, the unit has been changed to meters, but now I want to create a quarter of the square in which the length is 30 meters. And the other one 30 meters. Yeah, that's it. And repeat this square to make the bigger one. Use mirror command from create section. Then it asks you to select mirror plane. This is the mirror plane. And now repeat these edges. And this time by selecting the other mirror plane. Yes. Repeat the other edges, and now using trim away, trim these extra edges. Okay, so if you back to 3D mode, yeah, it is converted to a surface, and now it's time to extrude it about 60 meters so that the cubic would be created as the domain around the aircraft. But to extrude, we have to use pull command, click on it, then activate no merge, and extrude it about 60 meters. So whenever you activate no merge, the solid created is separated from the solid that you had before. Go to structure and you can see, yes, we have two solids. This one, which is the aircraft, and the other one, which is domain. But the thing is that because we want to only consider the airflow around the aircraft and how it behaves, we have to remove the aircraft inside. And so to do that, use combine command from intersect section, and first it asks you to click on a target object. This is the target object, and yes, and as a control object, of course, we should choose the aircraft. So as you see, the third solid is created, and if you click on this option, then click on the third one that is created, the solid inside is removed, but there is a solid inside that should be removed again. To do that, right click on it, then delete. So yeah, now we have only one solid, in which that if you see the geometry transparently, yes, the solid inside is removed, in which the walls are remained. It means that we can actually simulate the airflow around the walls of this aircraft. So yeah, that's it. Now we are going to transfer this geometry to ANSYS meshing. So close Space Clan window. After closing the Space Clan, you can see green check mark is activated for geometry, and then we can choose mesh from the toolbar and drag it to the workbench window. Then click on geometry and draw it to the box of B. So yeah, here we have the geometry, and now we can double click on mesh. So ANSYS meshing software will be opened. This is ANSYS meshing software that you can see the geometry is shown in this window, and this is a wireframe actually mode to see the aircraft inside. And if you back to this mode, you can see the geometry like this. And first we should check if the physics preference in mesh details is on CFD. Okay, and after that it's time to name the boundaries of the geometry so that we can set boundary condition in ANSYS Fluent more easily. To do that, from this toolbar, select face and then choose this face which is in front of the aircraft. Actually, right click on it, create name selection, and then name it as the inlet. And the other side, which is in the back of the aircraft, is named as outlet. And then the side around this one, do not forget to get Control key on your keyboard. Select the sides around, right click, name selection, and name them as symmetry. Yes. Let me check name selection here. Inlet, outlet, and symmetry. Yes, exactly. And then I want to name the walls of the aircraft. To do that, to select them more easily, we can select all surfaces. Then by unselecting the other faces except for the aircraft walls, so yeah, you can see all faces of the aircraft walls are selected, and now right click, name selection, and name them as wall aircraft. And here, back to this mode. So symmetry, inlet, outlet, and wall aircraft, which is all inside. To give size for meshing the geometry, first click on mesh, and here are details of mesh is shown. And we want to define the element size that I chose 1.8 meter as the whole element size, as the element size for the whole geometry. And pay attention that this geometry, because of having the aircraft, some surfaces are very small, and here minimum edge length is this value, which is very small. To have a better meshing, I change curvature mean size from default value to 0.001 meter, and then by defining the whole element size, the whole geometry element size, it's time to go and choose a method for meshing this geometry. Actually, I chose this method, and I tell you how to enforce method for meshing. Right click on mesh, insert method. Yeah, here it is. Of course, you have to Click on the body, then apply, and from here the method type should be selected. That I chose tetrahedron, and here the algorithm should be in patch independent. Okay, as you see, it is a repetitive. I just wanted to show you how to define this method. Okay, so I right click on it and delete, because I have patch independence defined for the body. Yes, the method tetrahedron and the algorithm patch independent. Okay, that's it, and we have the name selections, and it's time to right click on mesh, then generate mesh. So the process of meshing is started. As you see, the meshing is done, and now we can see inside the domain to see how the walls of the aircraft is meshed. To do that, go to wireframe and zoom in. Yes, here you can see how the aircraft walls are meshed. Okay, and now by right click on mesh, then update, you can transfer meshing data. As you see the message here, the mesh translation to Fluent was successful. You can transfer the data of meshing to ANSYS Fluent and start your simulation. Hope this video is helpful for you. To benefit from Mr. CFD services including simulation, consultation, and training, visit our website www.mrcfd.com or contact us via info@mrcfd.com.